Good morning, dear colleagues. It's my pleasure to be here with you today to present our work on the estimation of genetic gain in rainbow trout after 10 generations of selection in the AQUALANDE selective breeding program. This was done in the frame of the AquaIMPACT European project with colleagues from AQUALANDE, from CISAF, and from INRAE. Why do such an experiment? Well, to really show how selection can improve fish in a tangible way, like this experiment that has been done 20 years ago on poultry, and which really shows the difference between a control line and a selected line in a very practical way. We want to do this in fish. And to do this, we used the rainbow trout selection line started 10 generations ago in AQUALANDE in France, on which we focused on the so-called B line, which was selected for large trout production and fillet for smoking. And we want to see how it does compare with the original unselected line, which we will call G0, that was kept at AQUALANDE by random breeding. So by comparing G10 and G0, we can compare the gain obtained on all measurable traits, including yields, fat content, survival, etc., even those traits that are not usually recorded in the breeding program. And in addition, we wanted to test this with two feeds, the standard industry diet and a future sustainable and local feed. So to produce the groups, we crossed 30 G10 females with 30 G10 neo males, and then the same G10 females with 30 G0 neo males. So we made two genetic groups that differed only by the males. So the true differences between the groups will be 2 times higher than the ones we will measure. The G10 was selected for large trout, so for late growth, elongated shape, less viscera, and more muscle lipids to favor smoking. They were fed either a commercial feed or a future feed. The future feed had 0 fish meal, 0 fish oil, local ingredients like potato protein, 0 soy, and some yeast and microalgal biomass to get the DHA. In terms of design, we worked in AQUALANDE facilities, first in the breeding center of Pissos, where we compared the G10 and the G0 in triplicates until 250 days post-fertilization, where we tagged the fish individually. And then we transported them to Belin-Bélier, the on-growing site, where they were put in 12 compartments to compare at the same time the 2 lines and the 2 feeds, the Aqualia and the INRA feeds. And this was done until 374 DPF, where we slaughtered the fish to measure different quality traits. At that time also, we kept some G0 fish until 416 DPF so that they reached 1.6 kilo like the G10 at 374 DPF. This is the experimental setting in the Belin-Bélier farm with 12 cages in large raceways. In terms of results, we showed a better growth of the G10 with 20% more at the end of the experiment, which means 46% if we double the difference, because we compare only the males. No difference was seen before 192 DPF, so which means that, as expected, late growth was favored. And the G0, the ones we continued, they reached 1.6 kilo, 1.5 months later than the G10, which you can see here on the left. The feeds gave similar results in terms of growth. The future feed was a bit better at the beginning, but then it had the same result as the commercial feed. and we had no line by feed interaction. We had a higher condition factor in G0 versus G10, which was expected due to the selection pressure that was done on that. This was true at all times. There was no effect of feed and no line by feed interaction. In terms of FCR, at the end of the experimental period, we could see that the FCR was higher on the future feed on the right than on the industry feed on the left. And there was line by feed interaction because we could see no difference between the lines on the future feed, while there was a large difference in the industry feed. We think that this is due to the fact that as we worked in a fish farm, we cannot collect uneaten feed, and the way to measure feed intake was to feed the fish to near satiation. This was much easier with the commercial feed, which was floating, than with the future feed, which was sinking and where the exact ration was more difficult to determine. All in all, we see that the FCR of G10 on the Aqualia feed is 0.97 versus 108 for the G0. That's an 11% difference, or 22% again if we double the difference. Now, if we try to look at all the criteria, first at the same age, at the end of the experiment, at 374 days post-fertilization, and we try to look at the real difference, so the observed difference multiplied by 2. What would be a BG10 and a G0 fish? Well, you can see they have large differences in terms of body weight, growth rate, FCR, which is much improved, fillet lipid, visceral yield, which is much reduced, and a bit increase of fillet yield. The two fish that you see here are representative of this typical fish, BG10 and G0. But now, in real life, it's the market that decides the size. So the fish would be slaughtered at the same size. So we looked at the G10 and G0 at the same size. They still have different shape. They still grow faster, have more fillet lipid, but very little difference in fillet yield this time. Why? Because visceral yield is much decreased, but vertebral axis yield is much increased. Probably because of the selection for the longer shape. So in the end, what do we have? This G10 trout was improved for growth, for fillet lipid, for visceral yield, and for FCR. We could see no tangible improvement of fillet yield at the same body weight because we had less viscera but more vertebral axis. But indeed, the selection criterion that was used was visceral yield. So probably if we focus more on fillet in the future, we'll have better results even for this trait. We could see that the future plant-based feed gave good growth, but poor FCR, but we really think that this poor FCR is due to a technical problem of the sinkability of the pellets. We had very little genotype by feed interaction, and we had a really spectacular result of genetic improvement of FCR, for which we have very little data in the fish literature, where we compare a selected line against a control line. So this is a real important result of this study. I want to thank the European Union and the AquaIMPACT project, all our colleagues who work with us, and I want to thank you also for your attention. Thank you very much. Thank you.